Welcome to Quant 10, Target and Suspect Screening. Let's take a look at the Santé regulations and their view from accurate mass. First, there are two ions that are required for identification. We need mass accuracy better than 5 ppm. Signal to noise is a criteria. Coelution coefficient is a measure of shape. And ion ratio, which is always measured as part of the qualifier ratio in the target engine. Target screening and suspect screening happen in the same application, Quant, and with the same injection. Now, there's a difference between the target and suspects in terms of confidence, largely because the target has a standard and therefore a calibration curve, whereas the suspect does not have that same certainty in terms of confirming the compound. The Quant screening workflow is a simplified review by exception presentation. You'll find it in the Tools menu. Let's take a look at that screening. It shows you green for confirmed, a warning if the criteria are not all met, and then those that didn't make the cut. Those metrics are retention time difference, library match score, the target ion, its mass accuracy, and the number of verified ions. As stated, we are going to run the targets with calibration curves and the suspects with inherited calibration curves. And we are going to filter the findings against adjustable criteria. Targets have standards, and suspects do not, but can inherit, giving you an estimation. Let me note that we have two presentations. One is the screener, which is simplified, and behind that we have the details in batch at a glance to look at the specifics. And I encourage you to consider a dual monitor approach so that you could see all of that information at a glance. All right, let's take a look at the number of verified ions. So there's mass accuracy with its custom limits, less than 5 ppm. Coelution score, an indication of the adherence to shape between the target and qualifier. And then, of course, signal to noise, according to the Santé regulations. If all of those are sufficient, we've got a verified ion. Let's take a look at the definition for number of verified ions. We expect 2 ions, according to the regulations. We can find one, let's say the target ion. That's good, but to get to green, we have to find a target and another ion like a qualifier. So we have 2 ions found. In the screener, let's take a look at the positives, which are denoted in green. So if we look at the metrics, it's retention time, library match score, the target ion with its mass accuracy, and an aggregate that is the number of verified ions. Number of verified ions, you can see there's 3, and matching up with the spectra, target and qualifiers, there are 3 ions which are shown there to have been found, and their mass accuracy is annotated. Let's take a look at batch at a glance details on the other monitor. So for thalidomide, I see the calibration curve from the standard. I also see the overlay of the qualifiers, the confirming ions, from the target ion, and additional metrics like library match score, mass accuracy, signal to noise, qualifier ratio, and coelution score, which is the adherence to shape, and of course, mass accuracy. Let's take a look at a hit that's a suspect in the screener, in this case, propoxur 1. And you can notice it has a warning, that orange color. And if we follow that library match score warning to the ions, you can see that the 110 ion is very high compared to the others in terms of its ratios. If I look at batch at a glance details, I can see that for propoxur 1, there's a major difference here. The final concentration is grayed out as a visual cue that it's inheriting the calibration curve from malathion, which is what I set up in the inherit calibration setup. Thanks for your attention.